In this interesting case, we want to find the determinant of this 4 by 4 matrix. I want you to pay close attention to the third column, which has one non-zero entry and the rest of them are equal to 0. What are we going to do? We're going to use this column and write down the determinant of the matrix. The determinant of the matrix can be written as 3, which is this entry here, multiplied for the cofactor for the first row and the third column, plus 0 times the cofactor for the second row, third column, plus 0 times the cofactor for the third row, third column, and finally plus 0 times the cofactor for the fourth row and the third column. But note that these are all 0, so we don't have to calculate these cofactors. The only thing you need to calculate is the cofactor for the first row and third column, which is basically -1 to power 1 plus 3 times the determinant of this 3 by 3 matrix. Again, remember that when you have your matrix, you're getting rid of the first row and the third column, and we end up with a 3 by 3 matrix, and we need to calculate the determinant of this 3 by 3 matrix. We're going to go back and use the formula that we did before and calculate C1 and 3 using 0 times -1 to power 2 plus 1 times the determinant of 1, 2, 4, and -1. Where does this determinant come from? Since you're finding the cofactor for the second row and the first column, it means that these two disappear, and you end up with a 2 by 2 matrix. Then the next value is 2 multiplied by -1 to power 2 plus 2 times the determinant of this 2 by 2 matrix. And again, where does it come from? Since we are getting rid of the second row and the second column, we end up with a 2 by 2 matrix. And finally, the last entry is 3 multiplied by -1 to power 2 plus 3 times the determinant of this 2 by 2 matrix. Again, we are getting rid of the second row and the third column, so that's how you end up with this 2 by 2 matrix. When we do the calculation, it is equal to 13, but we are not done yet because we need to multiply 13 by 3. So the determinant of the matrix is equal to 39. So I highly suggest you to use the rows or columns that they have 0 in them and use those rows or columns to write down or find the determinant of the matrix. So for example, for this case here, at the beginning, since this column had a lot of zeros, we used this column to find the determinant of the matrix. But in the middle of the process, we need to use the second row. Of course, you can use the first or third row. No one's stopping you. You can also use the first column, second column, third column. But since this guy has a 0 in it, I know I can easily get rid of this quantity. It is 0 times a number. I don't even have to calculate this determinant. I just need to calculate these two values, add them together, and find 13. And finally, the determinant of the matrix is 3 times 13, which is 39.